Hello friends, today we will cover the two numericals based on the testing of IC engine. So we will start the first numerical. The fourth numerical is given here. We have in last video we have taken the three numericals based on the testing of IC engine. In this video we will cover the two numericals on the testing of IC engine. The fourth numerical is given here. Following observations were recorded during a trial of 4-stroke single cylinder oil engine. Okay, so some data is given. Duration is 30 minutes. Calorific value is 43 megajoule per kg. Area of indicator diagram 8.5 centimeter square. Length of indicator diagram 8.5 centimeter. Spring balance reading is 20 kg. Effective brake wheel diameter is 1.5 meter. Oil consumption equal to 7 liter. Relative density RD is given 0.8. Spring constant is 5.5 bar per centimeter. Brake load is 150 kg. Speed given is 200 rpm. Cylinder diameter is 33 centimeter and stroke is 45 centimeter. You have to calculate the indicated power, that is IP, then brake power, mechanical efficiency, brake specific fuel consumption, BSFC, and indicated thermal efficiency. So numerical is given here. You have to extract the data first. So we will first extract the data of engine. So number of cylinder is single cylinder. So number of cylinder is 1. It is 4-stroke. Therefore small n equal to half. Okay. The speed of engine n, capital N, is given is 200 rpm. Then cylinder diameter, that is bore diameter, capital D, is given is 33 centimeter, that is equal to 0.33 meter, and length of stroke is given is 45 centimeter, so 0.45 meter. Then here an indicator diagram is given. Okay, so indicator diagram. So with the help of indicator diagram we will calculate the indicated power. So let's draw the diagram first here. This is pressure and volume diagram, in which some diagram is given here like this. This is called as indicator diagram. It shows some area. It shows some area. So area of indicator diagram AI is given as 8.5 centimeter square. Then length of indicator diagram, it is denoted by Li, is given as 8.5 centimeter, and spring constant K is given as 5.5 bar per centimeter. Okay. You have to, for calculation of indicated power, you have to calculate the mean effective pressure. Mean effective pressure, we, for example, here consider this is the mean effective pressure PMR. So how to calculate mean effective pressure? PMR is equal to, with the help of indicator diagram, the formula is given as area of indicator diagram divided by Li, length of the indicator diagram, multiplied by spring constant. So it is given as AI is given as 8.5 centimeter square divided by Li 8.5 centimeter into 5.5. Okay, So it will give as 1 bar, sorry 5.5 bar. So PI we calculate here, PMI is equal to 5.5 into 10 to the power 5 Pascal. Okay, so we calculate the PI. With the help of this PI, we can calculate the indicated power. So this is the engine data. Okay, this is the engine data. Then we are going to find out the fuel data. Okay, so we have to find out the fuel data. So fuel data is given here. So volume is given, oil consumption is given, volume is given is 7 liter. We know that 7 into 10 to the power minus 3 meter cube. Okay. Then time of duration testing T is given as 30 minutes. 30 minutes. So it is in second is 30 into 60, that is 1800 second. Then relative density RD is given 0.8. We know that relative density is nothing but density of oil upon density of water is nothing but relative density. So therefore relative density of oil is equal to 0.8 into density of water is 1000 kg per meter cube. So it will give you the 800 kg per meter cube is density of oil. Okay. So with the help of density of oil, we can calculate m dot f. So what is m dot f? Mass flow rate of fuel. M dot f is formula is density of oil into volume divided by time. Okay. So I will write down here m dot f is equal to, what is density of oil is 800 into volume is given as 7 into 10 to the power minus 3 meter cube divided by what is time is 1800 second. So we will get the m dot f in kg per second is calculated as 3.11 into 10 to the power minus 3 kg per second. So we will calculate the m dot f. Then note down this the data. Then the dynamometer data is given. So we will in next slide we will find out the dynamometer data, or it is written as brake load is given as 150 kg. So converted into Newton. Converted into Newton. Brake load W is given as 150 150 So extract the dynamometer data. The W brake load is given as 150 kg. So converted into Newton, it is 150 into 9.81 will be the Newton. Then spring balance load is given as capital S. It is given as 20 kg. So 20 into 9.81 is Newton. Then effective brake diameter, effective brake diameter is given as dB plus dr, given as 1.5 meter. So this is the data we find out here. So what to calculate? We have to calculate first what to find. First one is the indicated power IP. Then second is brake power BP. Then third is mechanical efficiency, eta mechanical. Fourth one, brake specific fuel consumption, BSFC. Fifth one, indicated thermal efficiency. Fifth one you have to calculate is indicated thermal efficiency, eta indicated thermal. Okay. So you have to calculate this. So first we will calculate the indicated power, that is IP. It is calculated as, we know that what is the formula, PMI into A into L into N divided by 60 into number of cylinder into small n. So how to calculate IP? So we know that PMI is 5.5 into 10 to the power 5 into area is pi by 4. What is diameter? Is the diameter 0.33. Diameter of cylinder is 0.33 square. What is length? 0.45. What is N is 200 divided by 60 and number of cylinder is 1. So write down 1 here and small n is the half. So in denominator is 2. So if you calculate it is, so IP calculated as 35.28 into 10 to the power 3 kilo into 10 to the power 3 watt. Okay, into 10 to the power 3 watt. Okay, is nothing but IP 35.28 into is kilowatt. Okay. So we calculate the first parameter, that is IP. Then next we have to calculate the BP. Next we have to calculate the BP. What is BP? We know the formula with the help of dynamometer is given as W minus S into R effective, W minus S into R effective into 2 pi N by 60 is nothing but W minus S into dB plus dr divided by 2 into 2 pi N by 60. So put the values here. What is W? Is 150 into 9.8 minus 20. Here is the given one. All the values put here. 150 into 9.81 minus 20 into 9.81. This is the net effective load into dB plus dr divided by 2, that is 1.5 meter divided by 2 into 2 pi into 200 by 60. So it is calculated as 20.03 kilowatt, 03 kilowatt BP. Okay. Then third, you have to calculate mechanical efficiency. We know that mechanical efficiency is BP upon IP into 100. So put here IP is 35, BP is 20.03 kilowatt and IP is 35.28 kilowatts. So beta mechanical efficiency is calculated as 0.5682 is nothing but 56.82%. Okay. Then fourth one, you have to calculate BSFC. BSFC is brake specific fuel consumption. So it is, we know that Bm dot F into 3600 divided by BP. So put the values BP in kilowatt. Okay. So m dot F, we know that m dot F is 3.11 into 10 to the power minus 3, 3600 divided by BP. It is given as BP is 20.03 kilowatt. So BSFC is calculated as 0.559 kg per kilowatt hour. Okay. So this is BSFC. The last one you have to calculate. Fifth one is the indicated thermal efficiency. So eta indicated thermal, we know that IP upon m dot F into CV. So IP, we know that IP is 35.28. Put in kilowatt because CV is in kilojoule per kg. So m dot F is 3.11 into 10 to the power minus 3 and CV it is 43 megajoule. So we have to convert it into kilojoule. So 43,000. Okay. So calculate this. We find out indicated thermal efficiency is 26.88%. So this is the numerical. This is the numerical which is based on the indicator diagram. With the help of indicator diagram, we calculate the mean effective pressure, indicate mean effective pressure, and with the help of indicated mean effective pressure, we calculate IP, and so that we calculate BP and all the remaining parameters. So understand this, note down this numerical. The next one is numerical is air consumption for 4-stroke petrol engine. Air consumption for 4-stroke petrol engine is measured by means of circular orifice diameter 3.5 centimeter. CD is given 0.6. Pressure across the orifice 14 centimeter of water. CR compression ratio is given 6.5. Barometer reads 76 centimeter of Hg. Okay. Then temperature of air in room is 24 degrees centigrade. Fuel consumption is 0.13 kg per minute. Brake power is 27.968 kilowatt. The speed 2500 rpm. Displacement volume is given 1800 centimeter cube. Calorific value 43953 kilojoule per kg. Determine AFR, air fuel ratio, volumetric efficiency basis on air alone. Brake mean effective pressure, BME. Then relative efficiency based on the brake thermal. So you have to calculate 4 data. So first you have to find out the data here. So we can find out the data here. First one, we have to find out the engine data. So here we first extract the data from the numerical. So first we have to find the engine data. So engine data here is 4 stroke is given. So small n is equal to half. The number of cylinder is not mentioned, so we have to assume number of cylinder equal to 1. Okay. Then total displacement volume. Displacement volume is given. The displacement volume is given. So we have to take an Vs, displacement volume is pi by 4 d square into L. It is nothing but 1800 centimeter cube. So therefore Vs equal to 1800 into 10 to the power minus 6 meter cube. Okay. So data. Then brake power BP is given. Directly BP is given 27.968 kilowatt. Okay. Then speed of engine is given 2500 rpm. Then compression ratio CR, it is denoted by small r, or CR, it is given as 6.5. Okay. Any one data, and it is petrol engine. It is petrol engine. So note down this data. Okay. Then orifice data, you have to find out orifice data. Orifice diameter DO is given 3.5 centimeter, is nothing but 0.035 meter. Then CD value is given 0.6. Then pressure across the orifice HM is given 14 centimeter of water, is nothing but 0.14 meter of water. So therefore density rho m is nothing but 1000 kg per meter cube, because manometric fluid is water. Here meter of water is given. Okay, so manometric fluid is water. Understand? Then pre-atmospheric pressure is given. Here barometer reads 76 centimeter of Hg. So barometer reading is 76 centimeter of Hg, is nothing but atmospheric pressure, P atmospheric, is 1.01325 bar. Okay, so it is nothing but P atmosphere 1.01325 bar is nothing but 10 to the power 5 Pascal. Then T atmosphere 27. What is T atmosphere? 24 plus 273 Kelvin is nothing but 297 Kelvin. Okay. And find out density of air, rho of air, directly here. P atmosphere upon R into T atmosphere. So 1.01325 into 10 to the power 5 divided by 287 into 297 is equal to how much it is? Nearly 1.2 kg per meter cube. So this is the orifice data. Now find out the field data. Field data, calorific value, fuel consumption m dot f first. It is given as 0.13 kg per minute is nothing but 0.13 divided by 60, okay, kg per second, and CV of fuel is given as 43953 kilojoule per kg. So this is the data of this vehicle. So we have to determine air fuel ratio, AFR, air fuel ratio, then volumetric efficiency based on air basis of air alone, then brake mean effective pressure, third one, and fourth one relative efficiency based on the brake thermal. So first we have to calculate air fuel ratio. So we know that air fuel ratio AFR, air fuel ratio, is m dot A upon m dot F. So first you have to calculate m dot A with the help of formula. What is formula for m dot A? Rho of air into CD into pi by 4 dO square into under root of 2GHM upon rho m by rho A minus 1. So put the values here, total values. M dot A, density of air is 1.2, CD is 0.6, then pi by 4. What is diameter of orifice? 0.035 square into under root 2 into 9.81 into HM is given 0.14, density is 1000 divided by 1.2 minus 1. So m dot A, it is calculated as 0.0329 kg per second. So here we can calculate as AFR. So here AFR is calculated m dot A 0.0329 divided by, what is m dot F, is 0.13 divided by 60. Okay, so it is calculated as 15.2. It's calculated as 15.2. So AFR is calculated as 15.2. Okay, so AFR we calculate as 15.2. Then we have to calculate second volumetric efficiency, eta volumetric. We know that m dot A formula for eta volumetric is number of cylinder into rho of air into shaft volume into eta volumetric into n by 60 into small n. So m dot A we know 0.0329, number of cylinder is 1, rho of air is 1.2, shaft volume is 1800. Shaft volume is 1800 into 10 to the power minus 6 eta volumetric. What is speed? 2500 into 4 strokes, that is 1 by 2. So with the help of that, put the values here and calculate eta volumetric is calculated as 0.7435. Nothing but 74 point, nothing but 74 74.35% eta volumetric. Then third one you have to calculate is brake power, PMB. You have to calculate PMB. Brake mean effective pressure. So with the help of BP we know BP is equal to PMB into A into L into N divided by 60 into number of cylinder into small n. So we know BP is directly given 27.968 into 10 to the power 3. PMB you have to add it as it is, area pi by 4 d square So A into L pi by 4 d square is nothing but Vs. So directly we will put here Vs value rather than putting, because diameter and stroke is not given. Instead of diameter and stroke, directly swept volume is given. So directly we will put A into L, that is swept volume is 1800 to the power minus 6 into N 2500 divided by 60. Number of cylinder is 1 and small n is 1 by 2. So PMB it is calculated as 7.45 into 10 to the power 5 Pascal is nothing but PMB 7.45 bar. Okay. Now the last one, the fourth one, we have to calculate as brake thermal efficiency, a relative efficiency based on the brake thermal. So we know that relative efficiency based on brake thermal is given as brake thermal efficiency upon air standard efficiency. So first we have to calculate the air standard efficiency. It is based on the Otto cycle. We know that air standard efficiency is given as 1 minus 1 upon compression ratio to the power gamma minus 1. So it is 1 minus 1 upon compression ratio is given 6.5, gamma is 1.4 minus 1. So it is calculated as 0.527. Okay, that is 7 point. And then find out the brake thermal efficiency is BP upon m dot f into Cv. So what is BP is given in kilowatt, 27.968 divided by, what is m dot f, 0.13 divided by 60 directly given into 43953. So eta brake thermal it is 0.2936. So now calculate relative efficiency based on brake thermal. We know that the formula directly eta relative based on brake thermal is ratio of brake thermal upon eta air standard. So it is brake thermal is 0.2936 divided by, what is air standard, 0.527. So it is calculated as 55.7% relative efficiency. Okay. So here in this video we cover the two numericals based on the testing of IC engine. So that's it for today. Thank you.